This video covers the process of drawing a sample using simple random sampling techniques. Simple random sampling is often referred to as SRS for short. In practice, the process is fairly simple. You'll remember from the previous videos that SRS is a type of probability sampling. It's where we use the mathematical meaning of chance to assure that each case has a known and equal chance of being selected. Simple random sampling does quite well to meet the requirements of probability sampling. You will recall that sampling is a process where we start with some collection of cases that we're interested in, the population. It's a process where we select out some smaller portion of this population that accurately represents our population and allows us to make conclusions about the population based on information we collect from the sample. In practice, SRS begins with acquiring a complete list of everybody in our population. Remember that our population is made up of units of analysis, the thing that we're interested in making conclusions about. So it could be Americans, if that's what we're studying, or college students, or Portlandians, cars or car accidents, cities, whatever it is that we're studying. The key for SRS is that we need to devise a way to select from that list our sample that ensures that everybody has a known and equal chance. That is, that it's completely random. This can be accomplished in a remarkably simple way. It involves cutting our list into individual pieces that include one unit of analysis per piece. We then place those strips into a hat or a box or some kind of bin, something that will hold all of our strips. We then simply need to shake up the box and then select at random from the box our sample. This does a remarkably effective job at assuring that each case in our sample has a known and equal chance of being selected. Of course, the equal chance is assured by selecting at random from the box. Determining each case's known chance takes a little math. It's simple, I promise. All we do is take the size of our sample and divide by the size of our population, and that equals K. K is our sampling fraction. If, for example, our population equaled 100,000 and our sample equaled 1,000, K would equal 1,000 divided by 100,000, or K equals 1 over 100. This means that in our population, each case had a 1 in 100 chance of being selected. One thing to know in SRS is the quality of our sample depends heavily on the quality of the list. Essentially, a quality list will have no omissions and no duplications of cases. In theory, we want that perfect list with no omissions and duplications, but in practice, that is nearly impossible. In real research, we do the best we can, get the best list possible, and hope that we can draw a representative sample. It's also important that we be honest when our list is less than ideal. In practice, SRS is a remarkably simple and remarkably effective way of drawing out a sample.